Okay, guys, how are you today? All right, today we're going to be learning another way. Another way. We've learned two already. We've learned Kramer's rule. We've learned how to use inverse matrices to solve systems of equations. Today we're going to learn another way of solving systems of linear equations using matrices. All right. Now, in your notes, it says the matrix used to represent a system of linear equations. Got some candy in my mouth. I'll take it out so I don't make noise. Is called a what? All right, it's actually called an augmented, this word right here, augmented matrix. All right, so we're going to write that here, augmented. All right. All right, so we have an augmented matrix, all right? So, and they give us an example right here. So we have a linear system, x plus 4y equals 14, 3x minus 2y equals 0. We can write this as an augmented matrix. It will look like this, all right? So this is a little bit different than the matrices that we've been using because now we have this like line down the middle. And this line is just there to help us separate. It's not really that important. It's just there for us to help us separate the coefficients of the variables, which are 1, 4, 3, -2, and then our constants on the other side, 14 and 0. All right. So we write our augmented matrix like this: 1, 4, 3, -2, and then 14, 0 over here. And we just treat this as if it's just one matrix. All right, this is a matrix. All right. So the coefficients are on the left, and the constant terms, which are 14 and 0, are on the right. Okay. So number 2 here is an example. It wants us to write the augmented matrix of a system of equations. So here we have a system of equations. We need to write the augmented matrix. All right. How do we do that? Well, it's pretty easy. Again, so we're going to make a matrix, all right? And on this side of the line, we're going to have our coefficients. And on the right side of the line, we're going to have our constants. Now, our constants we can see here are 4, 8, -4. All right, so we have over here, we're going to have 4, 8, and -4. And then over here on this side, we're going to have, now be careful, sometimes there are variables missing. So for example, here we don't have a z. So that means our z is going to be 0. So we're going to have 3, -2, 0. All right. And then this one we have 2, -4, 5, 2, -4, and 5. And on this one, we have a z, we have a y, but we don't have an x. So the x is going to be 0 here. And then the y is 3, and the z coefficient is 4. All right? So this is the augmented matrix for this system of equations. All right? Pretty easy. We already did it. That's all. All right? Or we could go the other way. So in this one, we have the system of equations, and we can write our augmented matrix. In this one, they gave us an augmented matrix, and we can write a system of equations that this represents. All right. So we usually write a system of equations with a bracket on the side. They didn't over here, but usually we do that. All right. So here we're going to have a system of equations. And we're going to say this is all of the x variables, this is all the y variables, and then these are the constants, all right? So we're going to have -2x plus 3y equals 5. And then this one's going to be 4x plus 2y equals -6. And that's it. This is our system of equations represented by this augmented matrix. All right. So you should be able to do both ways. If I give you a system of equations, you can write the augmented matrix. Or if I give you an augmented matrix, you should be able to write the system of equations. Both are pretty easy to do. Now, actually, let's do one more example before I get into the more difficult stuff. Let's do one more example. This is in the textbook here. This was on page, let's see, what page? Page 713. Okay, yeah, right here. We're going to do this one. Okay. So let's look at B here. All right. So ignore this. Ignore A. Let's look at B here. So this is something you need to be careful of when you're working on these. All right. So we have a system of equations here, and we need to write the augmented matrix. All right. So we're going to write an augmented matrix. Now, again, it's going to look like this. We're going to have matrix over there. We're going to have a line down the side, and then we're going to have something over here. Now, be careful, though, because it looks like, oh, 0, 0, 0. So we can just write zeros on this side, and then we have 2, negative 1, 1, 2, negative 1, 1, 1, 1, negative 1, 1, 1, negative 1, 1, 2, negative 8, 1, 2, negative 8, and we're done. No, that's not right. Be careful. You need to look for the coefficients. All right, look here. This is an x, this is a z, but this doesn't even have anything. This is just a constant, which means we need to move it over here. So we should plus 1 to both sides. This goes away, and this becomes 1, all right? 1 over here. Also, here, this is negative 8. That's a constant. So we can plus 8 to both sides. This goes away, and this becomes 8, all right? And now everything over here is coefficients, and everything over here on this side are constants. All right, so you need to make sure that all of your coefficients are on one side with the variables, and then your constants are on the other side. You have to do that first before you can make your augmented matrix. So now we have fixed it. We can go ahead and make our augmented matrix. All right, so 0, 1, 8 are going to be our constants over here. And we need to look carefully at the variables and what the coefficients are. Let's put the x's in this column, the y's in this column, and the z's in this column. Well, our x, y, and z here are 2, negative 1, 1. So we have 2, negative 1, 1. And then here we have 1x and 1z, but no y. So it's 1, 0, 1. All right, 1, 0, 1. And then here we have an x and 2y, but no z's, all right? So we're going to have 1, 2, and then 0. All right, 1, 2, 0. And this is the augmented matrix for this system of equations. So be careful. Tonight in your homework, you're going to have problems like this, and you need to make sure that you get all of the constants on one side first and all the variables and their coefficients on another side, and then you can make the augmented matrix, all right? Okay, so let's go back to our notebook here, and we're going to talk about the more difficult part, all right? This is a little bit tricky, so please pay attention, all right? We're going to be talking now about row operations. Now, row operations are things we can do to the rows of a matrix, all right, that will not change their, it's hard to explain. It won't change their relevance when we're talking about the system of equations. Let me give you an example. Here, it says we can interchange any two rows. All right, what does that mean? That means, well, let's say I have an augmented matrix. 2, 0, and let's say this is 6. I'm going to put a line down here. And then maybe this one is 3, 4, 2. I don't know. Let's just put, let's see, let's say 11. All right. Okay. So let's say we have this matrix, this augmented matrix. Now, row operations are things that we can do to the rows that's not going to change the way this system of equations works. So, for example, I can interchange any two rows. What does that mean? It means I can switch the rows. I can put this one on top and this one on bottom, and it's still the same thing. All right, and that's true, of course. What is this? This is 2x, 0y, so 2x equals 6. And this is 3x plus 2y equals 11. All right? Well, this means if I switch these two, now we're going to have on the top is 3x plus 2y equals 11, and on the bottom is 2x equals 6. But that's the same meaning. It doesn't change the value of x and y if we just switch the rows. So that is a row operation. We can do that, and it doesn't change our system of equations. The system of equation still remains the same. All right. Another thing we can do is we can multiply a row. A constant multiple means we can take a number and multiply the whole row by that number. Well, does that work? Well, let's think about it. If I have this one, which is 2x plus 0y equals 6, so that's 2x equals 6. If I multiply this whole row by 2, all right, just the row, not this row, just the top row here. If I multiply that whole row by 2, what does that change it to? That changes it to 4, 0, 12, which is 4x equals 12. I just multiplied everything by 2, right? But does that change the equation? No. 2x equals 6, well, that means x equals 3, right? 4x equals 12, well, that also means x equals 3. It's the same. It doesn't change it at all right? I could multiply it by 5, and it would be 10x equals 60. I'm sorry, 10x equals 30. Well, 10x equals 30, that means x equals 3 again. I could multiply by 20, so that would be 40x equals 120. That means x equals 3 again, all right? It's always the same. So we can multiply a row by a constant number, and it doesn't change the equation, all right? All right. So that's a row operation. That's a row operation. And the next row operation that we can use is we can replace a row by the sum of that row and a constant multiple of some other row. Now, this one's a little bit more difficult to understand, all right? But what it means is that it's not going to change the equation if instead of writing 3 to 11, maybe I could write a multiple 2 times this row plus this row, and it's going to keep it the same. Now, I know that's hard to understand when I speak it, but let's look at how this one works, all right? So we're going to do an example of how to do a row operation. Now, this can get confusing, so please watch carefully so you understand this. All right. Now, here we have a big R2. That means our new row 2, all right? That's what big R2 means. It means the new row 2. It means we are going to change the second row. We're going to give a new second row, all right? And then the little R1 and the little R2 are the old rows, all right? The old rows, all right? So when we're doing these row operations, if you see a big R, that means the new row. And if you see the little r, that means the old rows, all right? So what is this saying? It's saying that our new row 2 is going to be -3 times our old row 1 plus our old row 2, all right? So that means we are changing row 2. We are not changing row 1. There is no big R1 here, right? It's just big R2. So our old row 1, which is this one, 1, -2, 2, it is not going to change. So it's going to be 1, and I'm going to give a little space here. I'm going to put some space. I'm going to write 1, -2, 2. All right. So that is the first row of our new matrix, all right, because we're going to be changing it. Now, our second row is going to change now. How is it going to change? Well, each entry is going to be -3 times the first row, the old first row, plus the old second row. So how does that work? Well, let's look at the first one here. We're going to have -3 times R1, that's our old first row, which is 1 here. And then we're going to add our old second row, which is this one, 3. So plus 3. And that's it. Now let's go to the next one, all right? This entry right here, well, it's going to be -3 times our old first row, which is right here, -2, plus our old second row, which is this one right here, -5. So plus -5, which is -5. Okay? And then our final one right here, again, we're going to say -3 times our old first row, which is 2, plus our old second row, which is 9. All right, now we just simplify this, all right? And we're going to get 1, and then -3 times 1 plus 3 is -3 plus 3, which is 0. Okay. And then right here, our first row, second column is going to be -2. And then our second row, second column is going to be -3 times -2, which is 6. And then we're going to subtract 5. So 6 minus 5 is 1. Good. Then we're going to draw our line down because this is an augmented matrix. The first one here is 2. And then the second one here is -3 times 2, which is -6, plus 9 is -6 plus 9 is 3. So we have 2, 3. And that's it. We're done. We did a row operation on this matrix. Now, the cool thing about row operations is that it will always keep the system of equations that we're working with the same. So this one and this one are actually the same. They represent the same system of equations, just in a different way. Okay? So same system of equations in a different way. So we're going to do this again. This one is even harder, all right? It's not too hard. It's just it takes a little bit of time to figure out what exactly we're doing. All right? So we're going to do this one. This time we have big R2, so that means we're going to have a new second row. And we have a big R3, which means we're going to have a new third row. All right? So we have a new second row and a new third row. Okay? So what's this going to end up looking like? Well, let's work on it. So here we go. We're going to write it. Now, our first row is not going to change. So it's going to be 1. And then it's going to be, I'll write it over here, -3. And then I'll give a little space here and 4. And then I'll draw the line because this is an augmented matrix. And we'll have a 3 here. All right, so that's our first row. All right, and then I'll finish the matrix like that. All right, so that's our first row. 1, -3, 4, 3. It didn't change. But our second row is going to change. We have a new big R2, so that's a new second row. What is our big R2? It's going to be -2 times the old first row. So what's the old first row? 1 times 1. And then plus the old second row, which is this one. So it's going to be plus 2. Okay. Let's move on to this one. All right. -5. Well, this is going to be -2. We have to keep it -2 times R1, which is the old first row, which is -3. And then plus the old second row, which is -5. So plus -5 is -5. Okay. And then our next one here, that's going to be, again, -2 times our old first row, which is 4, plus our old second row, which is 6. Okay, good. And then our last one in row 2 is -2 times our old first row, which is 3, plus our old second row. Oops, didn't want to do that. Plus our old second row, which is 6. So plus 6. Okay. So we have now completed finding our new R2, our new second row. Now we also need to have a new third row. Okay, so how do we do that? Well, it's going to be 3 times our old first row. So it's going to be 3 times our old first row, which is 1, plus our old third row, which is -3, so -3. Then we have this one is going to be 3 times our old first row, so it's going to be 3 times -3, and then plus our old third row, which is 3, so plus 3. Okay, and then we have this one, which is, again, 3 times our old first row. 3 times our old first row is 4, plus our old third row, which is also 4, so plus 4. And then finally, the last one here is going to be 3 times our old first row, which is 3, plus our old third row, which is 6. All right, and that's everything. We just need to simplify it now. All right, and what is this going to look like? Well, it's going to be 1, then -2 times 1 plus 2 is 0. Then 3 times 1 minus 3 is 3 minus 3, which is 0. All right, then we have -3. Then we have -2 times -3, which is 6, minus 5 is 1. 3 times -3 is -9, plus 3 is -6. Then we have 4. Then we have -2 times 4 is -8, plus 6 is -2. 3 times 4 is 12, plus 4. 12 plus 4 is 16. And then we're going to write the straight line down. And the final column is 3. And then negative 2 times 3 is negative 6 plus 6. Negative 6 plus 6 is 0. And then we have 3 times 3 is 9 plus 6 is 15. And so that's what we get. And this is our new augmented matrix after we did these two row operations. All right. So tonight in your homework, you're going to have to do this. You're going to have to, we're going to give you a matrix and you're going to have to perform row operations on the matrix. All right. So I will give you, or the book will give you, row operations like this, and you will have to use the row operation to make a new matrix. All right. All right. Now we're going to do one more example, and it's back in the textbook here. All right. So right here on this one, let's look at this problem. So it says we want to find a row operation that will result in the augmented matrix. So this matrix, we want to make it have a 0 in row 1, column 2. Now, real quickly, where is row 1, column 2? Well, here's row 1, and here's column 2. So this one is row 1, column 2. We want this to be a 0. We want to make this a 0. How can we make this into a 0 using row operations? Now, real quickly, remember, what are the row operations that we can use? These are the only 3 row operations we can use. There's 3 of them. We can change, all right? We can change the rows. We can switch them. This one can go down here. This one could go up here. But will that make this a 0? No, that won't help. So this one isn't going to help us. What else can we do? We can replace a row by a non-zero constant multiple. This is important, non-zero. If we multiply everything by 0, that doesn't work. We can only do it by a non-zero constant. So does that row operation help us here? No. Can we make this a 0 by multiplying by a non-zero constant? No, the only way to make this a 0 is if we multiply by 0. But we can't do that. So this one doesn't work either. So A doesn't work, B doesn't work. So we're going to have to use C, which is one of these type of row operations. All right, where we're going to, sorry, I keep clicking on the wrong thing, where we're going to have to replace this row. All right, so we're going to have to make a new R1, all right, so big R1, and we're going to have to use this, we're going to multiply this row by something and then add it to this. Well, what can we do to make this a 0? Well, this is a 1, so if we multiply this 1 by a 2 and then add it to hit this, so this will become positive 2, and then we plus negative 2, that's going to be 0. That's what we want. So if we want to try and make this into a 0, what we can do is we can say 2 times row 2, because this is row 2, old row 2, right? And then we're going to add it to row 1. All right? That's what we can do. If we do 2 times this row and we add it to this row, we're going to get a 0 here. And that's what we wanted. We want to have a 0 in this column. Okay, so let's go ahead and do that. We're going to use this row operation on this matrix. So real quickly, let me change to a different pen. All right, so I'm going to write equals. All right. And I'm going to now write our new matrix. All right, so it's going to be, on the top is going to be this. All right, so we're going to have 2 times R2, which is the old row 2, which in this one is 0. And then we're going to plus old row 1, which is 1. Good. And then now we're going to move here, and we're going to do 2 times old row 2, which is 1. And we're going to plus old row 1, which is -2. So that's going to be -2. And then we're going to write our line down here. And again, we're going to go 2 times old row 2, which is, old row 2, which is 3. And then we're going to plus old row 1, which is 2. And then our second row isn't going to change. So this is going to be 0, this is going to be 1, and this is going to be 3. All right, so now we can go ahead and write our final matrix here. Well, 2 times 0 plus 1 is just 1. 2 times 1 minus 2 is 2 minus 2, which is 0, which is what we wanted. We wanted to have a 0 in the second column, first row. Row 1, column 2, we got a 0. That's what we wanted. We did it. All right, and then we're going to draw a line here. And what's over on this side? Well, 2 times 3 is 6 plus 2, so this is 8. All right, and then the second row didn't change at all, so it's just 0, 1, 3. So now we have this matrix, which matches what we wanted. We wanted to have a 0 right here. So that's another thing you need to know how to do, and we will use that more tomorrow's lesson. Not tomorrow, tomorrow's Saturday. Monday's lesson. All right, on Monday, we're going to be using this idea a little bit more. So we didn't even get to solving systems of linear equations yet. But in order to do that, first we need to know how to do these row operations. So today, we're going to practice row operations in our homework. All right, I hope you understand that. Again, if you don't understand it, please send me a message. Let me know. I'll arrange a time to talk to you. All right, bye-bye.